The general topic of this week's lectures is actually the developmental origins of health and disease. And I thought that it was just worth it to basically describe the person that at least was instrumental in starting this whole discussion. David Barker, who died in 2013, last year. But basically he was the person, he was mostly an epidemiologist, and you will see basically the data that led to the discovery, the importance of the developmental origins for health and diseases. If you are interested, there is one episode that actually from a TV program from the Swedish television that was broadcasted in April 2013. I think that you can see it online. So it's specifically about this topic, the developmental origins of health and disease. The first micro lecture in this topic is actually, I'm going to present the epidemiological evidence collected by David Barker and others that led to the main findings. And the main basis of the work by David Barker is actually on a large health record from a county in England, the county of Hertfordshire, in particular one side of the country, in which between 1911 and 1930 there was a little bit over 100,000 inhabitants. It was a district that had a very relatively low infant mortality, below the national average. 49 children that died for every 1,000 births. It's also an area, or it was an area characterized by no major industries. This is important in terms of pollution, so we will see later why. And most people was employed in agriculture, trade, on services. So this big health record that you'll see in a second, basically from this particular site or this particular county in England led to the first discoveries about the developmental origins of health and disease. Of course, within that context, in that historical context, all births took place at home. There was no hospital that births took place. And essentially, they were attending midwives that traveled from house to house, from home to home, helping in giving birth. But these midwives, particularly in this county, had the obligation to report to the county medical office for every birth that she attended. So in this case, there was a record. For every birth, there was a record that included the name of the mother, the address of the mother, the date of birth, the birth weight, the size of the mass of the child at birth, but also there was a follow-up and the weight at 1 year of age, and also feeding conditions, if the babies were breastfed or were bottle-fed. Of course, from this data set, it was possible, and that was the big discovery by David Barker, just to look at the national health records many years after and see basically what had happened with these babies that were born between 1911 and 1930. And what they basically could relate is what was the importance of birth weight in relation to the cause of death or in relation to the mortality. What David Barker and most epidemiologists measure is what's called the standardized mortality ratio. And this is actually the ratio of your study cohort. In this case, the study cohort is babies born in the county of Hertfordshire, basically between 1911 and 1930. And the comparison between the mortality ratio for this cohort with the average population, the whole of Britain. In this graph, you see the results, and in this graph, basically, you see lines that are joining points with equal risk. And in between, I've drawn this line of the 100%. This is the line that would correspond to the same or to the average in the whole country. So basically, what you see here is the distribution of our cohort individuals within this two-dimensional plot, depending on their birth weight and their weight at 1 year of age. And what you see clearly here is that below the 100% line, indicating that the cohort group actually had a higher mortality ratio than the national average. When does that happen? As you see, it happens below a weight at 1 year of around a little bit above 22 pounds, and a weight before, or a birth weight slightly below 8 pounds. From this point towards the smaller size, what you see is that the mortality rate of the babies, or of the individuals in the cohort, is larger than the average national. Particularly, this is even more enhanced when you look at the smallest of them. Babies that were below 5 pounds, at 1 year of age below 17, 18 pounds, these babies had a much higher mortality than the average national mortality. So obviously this was important information indicating that the size, the mass at the time of birth was important in determining your future odds. The outcome of this study, therefore, is that low birth weight, or if you want also the weight at 1 year of age, is important because actually in this case it increased the risk of death, the risk of ischemic heart disease as well. Ischemic heart disease is that situation in which the heart does not receive enough oxygen and basically it suffers from what would be a heart attack, a heart infarct. And another outcome from this study was that promotion of postnatal growth may be especially important in boys who weigh below 3.4 kilos at birth. So the proposition in this case was, if you were born small, it was important that you had to grow more postnatally. This is what at that time, well, it's still called the catch-up growth. Nowadays we know that this is not the case, and you will see that later in the lecture. So this was an outcome from this study that was not particularly successful, because in the light of what we know today, it's understood that if you are born small, it's better that you stay small than instead you try to grow much faster later on in life. This is the same data set, in this case showing the standard mortality rates for ischemic or for heart disease in men and women of the cohort, of the same cohort for this that I was describing. If you then, instead of actually plotting birth weight, you use the weight at 1 year of age, you see exactly the same trend. The smaller you were at one year of age, the smaller you were when you were born, the higher your odds of dying of heart disease. This is not unique for this cohort, the cohort of Hertfordshire in Britain, but it has been shown also from some cohorts in this case in Finland. And finally, and that's the other example I want to show you, is basically the Dutch famine cohort. This is a study also that has yielded a lot of interesting results. We will see it also a little bit later. But basically, this Dutch famine cohort is a group of babies that were affected by malnutrition at the very end of the Second World War in Holland. In Holland at that time, when the Allies disembarked in Normandy, basically, and tried to basically reconquer the different occupied, German-occupied countries, they encountered a large resistance at this point here, which is basically the crossing of the River Rhine. In this crossing, they were not able to cross the river, therefore the whole how to say? Well, basically the expelling the German troops from these territories was not possible because they failed to actually go across the Rhine River at the Battle of Arnhem. As a consequence of that, what happened is that the German forces retaliated by isolating completely this area of Western Holland. This area of Western Holland, you hardly see it in the map, includes the city of Rotterdam, and outside of the map that you cannot see, the city of Amsterdam. This was a large area with a lot of inhabitants, about 4.5 million. Out of these, 22,000 died during the period of the famine. Combined with this problem, lack of supplies, lack of food, lack of fuel for heating, combined with this, basically a harsh winter. A very harsh, a much colder winter than in previous seasons, which meant that this population was undernourished and they did not get enough food, but also they had actually problems for heating, for cooking, etc. There were essentially no supplies. Here you see an example of the food ration that the Dutch living in these territories basically was able to consume. A couple of pieces of stale bread, a couple of potatoes, some root beets. As you see, that's not much nourishment in these meals. Basically, the intake, the energy intake at the end of February 1945 dropped down to 580 kilocalories per day. This does not mean that people did not follow their regular life. Of course, women became pregnant, and became pregnant during different periods of this famine. As a consequence of this was malnourished mothers that presumably also could not properly nourish their fetuses. And this actually imposed a period of malnutrition very well defined in time. As a result of this, basically, we have also learned some similar processes to what was learned from David Barker's study. Similar consequences associated with malnourishment, with malnutrition during pregnancy. In this case, we have known, it's been discovered that children of pregnant women exposed to the hunger were more susceptible to diabetes, more susceptible to obesity, cardiovascular diseases, and other health problems. So same observations have been seen in the Hertfordshire cohort, in the Dutch famine cohort, in the Helsinki cohort, and many other studies that are taking place at the moment. As also an outcome of these studies on the Dutch famine, basically it was the discovery of the celiac disease or the gluten intolerance. This is a side note, but basically there was a pediatrician that during this time of the Dutch famine observed many less cases of celiac disease. And as soon as bread was available after the war, then these cases increased again. As a result of that, they discovered gluten intolerance. So basically, from this set of studies, we can conclude this lecture with Barker's hypothesis. What David Barker realized is basically that certain anatomical and physiological features get programmed during embryonic and fetal development. What he realized is that depending on what happens during pregnancy, things can become fixed. And changes in nutrition, in particularly during this time, during the time of the pregnancy, can produce permanent changes in the pattern of metabolic activity. This was a rather important discovery at the time, and I think that it's a heavily active area of research today as well. Thank you very much.